Now on this page, we'll look at some examples and apply the ideas of direction, form, strength, and outliers to describe the relationship in a scatter plot. So we'll look back at that same example we saw on the first page of this module, age and reading distance. So the scatter plot of the driver's age and the maximum distance they can read on a highway sign is below. The direction, so it looks like the direction of the relationships is negative because we said before that lines or curves that slope downward from left to right are negative directions. An increase in age is associated with a decrease in reading distance because as I go to the right and I look at larger and larger ages, 15, 25, 35, I see that the Y values are going down. These points have large Y values because they're high up, but as I go looking off to the right, I see that the Y values are getting smaller. So basically, as we get older, our maximum reading distance gets smaller. So our age gets bigger, but our reading distance gets smaller, which makes sense because older drivers tend to have diminished eyesight and can read the sign only when they are close to it. In other words, they have a shorter maximum reading distance. Now we'll look at form. The form of the relationship looks fairly linear, I'd say. It doesn't look perfect, of course, but I'd say it looks closer to a line than it does to any kind of curve. Let's see. The strength, how strong is it? Like I said, it's a relative term, strength, but the data points are fairly close to the line. Not great, but they're fairly close. I mean, to where I can tell it's a line and not just a big blob of points, I guess. So the relationship is moderately strong. It doesn't look great, but it looks all right. So it's moderately strong. Don't worry if you feel uncertain about describing the strength of the relationship. Like we mentioned earlier, that describing the strength is not very precise. We develop a more precise measure of the strength soon. Outliers, there are not really any outliers. All the data points tend to follow the linear pattern. Although this guy here, I would say he looks kind of far away, but he has a couple of friends that are not too far away from him, and it's not like a bunch of them are all close together and one way off by himself. There are a few, almost like a trail leading to that one that's far away. So it's maybe not an outlier. If that one is considered an outlier, you probably have to include a lot more as the outliers. So we'll just say no outliers. And there's more precise ways to say whether something is an outlier or not. Again, just like there's a more precise way to tell what the strength of the form is. Let's see. So now we'll talk about outliers in the scatter plot more closely here. In a scatter plot, a point is an outlier if it deviates from the general pattern in the data. A point can also be an outlier if it follows the general pattern, but its X or Y value, or both, are substantially large or smaller than all the other data points. The next example provides a good context for discussing an outlier. We'll talk about the average length of pregnancy for different animals now. What is the relationship between an animal's lifespan and the length of its pregnancy? To investigate this question, we have data from 40 different species of animals living in captivity. We use average lifespan as an explanatory variable X. The average length of pregnancy is the response variable Y. Now we'll scroll down and look at the scatter plot here. Okay, we don't know which animal is which, we just know all the dots are here. So what can we learn about the relationship from this scatter plot? It looks like it's sloping upward, so I'd say its direction is positive, sort of, even though it looks more like this triangle shape, like the longer you go in years, or the older, I guess, the older they get, the more variation it seems like. It seems like it's not linear. At the beginning it looked linear, but toward the end it doesn't look linear. It looks very wide right there. Direction. The direction of the relationship is positive. An increase in lifespan is associated with an increase in length of pregnancy. In other words, animals that live longer tend to have longer pregnancies. But you'd see this one over here. That's quite an outlier, it looks like. In that case, it looks like the X value and the Y value are much larger than all the rest. Here's the lifespan of that guy. He lines up with about 40 or a little more than 40 years. And then for length of pregnancy, it looks like between 600 and 700 days. That's quite a bit. The form of the relationship is linear, I'd say. Basically, yeah. I mean, there's no curve. Even if it had the same kind of spread, how it seems like it's very spread out toward the top. If it looked more like this at the bottom, or that I'm showing kind of here, maybe it's hard to see. I'll try to do it darker. All these points, they've got the same kind of basic triangle shape, but they're more curving, it looks like, rather than this one's looks like it's more straight, like a straight line, even though they don't all really lie right on that line. But it looks, yeah, a lot more like a straight line than we could see in other ones. It's basically linear. Let's see if the relationship is strong. What kind of strength does it have? The relationship is fairly strong. This is a judgment call at this point. Like we said, we'll learn more ways precisely to determine the strength of a linear relationship soon. But notice that the variation in pregnancy length is larger for animals that live longer. For example, animals that live 5 years have pregnancies that range from about 30 days to 120 days. The short red vertical line, this one, on the left illustrates this range. Animals that live 12 years have pregnancies that vary more. That's this larger vertical line. It just goes from the very lowest length of pregnancy for some animals that live 12 years to the highest length of pregnancy for an animal that lives 12 years. It ranges from about 60 days to over 400 days. The longer red vertical line on the right illustrates this range, like we said. So the relationship is stronger for animals with shorter lifespans. Now we'll look at outliers. There is a data point that deviates from the rest of the data because it has large X and Y values. This is the elephant. Elephants live a long time relative to other animals. It has a large X value, so because it lives a long time, and they have long pregnancies. That's a large Y value. The elephant is an outlier in this distribution of both the lifespan and the pregnancy variables. But this data point follows the positive direction of the data and fits the linear pattern. With respect to the form and direction of the relationship between the variables, this point is an outlier.